Welcome to the Drexel App Lab's 5th Xcode 7 and Swift 2 screencast. Today we will be taking the alien game we have been working on throughout our previous screencasts and adding some randomness to our aliens and our spaceships. If you haven't started this project yet, please check out our previous Swift screencast for instructions on how to begin. We'll kick this screencast off by writing code to help us generate our alien and spaceship in random positions in our view. When we add more aliens and more levels, this will help to keep our game fun and challenging. To begin, we'll write a new function called randomSquare to create a CG-rect object that is the correct size for the object it is being called for, but that is random in its position in our view. You might remember that our ship frame and alien frame from the last screencast were both CG-rect object instances. We will be writing our randomSquare function so that it returns a CG-rect object that we can use in place of either of these frames, so that the position of our alien or of our ship is randomized. Because randomSquare is returning an object, the function is defined a little differently than we've seen previously. To start, we will type this line of code. This function will take one argument, which is the length of a side of the frame we want generated for us. This will ensure that our alien and spaceship don't get stretched out when we randomize their positions. Func lets our code know that we're writing a function. randomSquare is the name, and sideLength:int tells our function that it will be getting one argument of the data type integer, named sideLength, that it can use in its execution. The CG-rect portion of our code lets our function know that it will be returning an object of the CG-rect type. This allows the code that calls this function to be sure that it knows what kind of object it will be getting back, so it can be prepared to use this object properly. Inside of our curly braces for this function, we will write this line. This uses functions that are built into Swift to create a new function called random that we can then use to generate random numbers to use for our x and y coordinates. To use this, we will type these lines of code. These create two variables, x and y, which are each equal to the result of their individual calls to the random function. Let's use our new random x and y coordinates to make a new CG-rect object in our function. We will use x for our x coordinate in our CG-rect and y for our y coordinate. We will also use our sideLength argument to ensure that the new CG-rect object is the proper size. To create this new frame, we will type this line. Because random creates very large numbers, we will utilize a mathematical function called modulus to limit the size that these can be, so we can ensure that the x and y coordinates will not place our spaceship or our alien outside of our view. To do this, we will add %250 to the end of x's declaration and %500 to the end of y's declaration. This takes the remainder of the call to the function when divided by 250 or 500, and thus limits the size that either number can be. X can't be any bigger than 250, and y can't be bigger than 500. We will then tell our randomSquare function to return this object when the function is called, so that whatever piece of code calls this function can use the new object. Now when we call this randomSquare function, we will get back a new, randomly positioned CG-rect object that we can use as the frame for our alien and ship buttons. To make use of this, we will replace our alien frame and ship frame with calls to the randomSquare function, both with an argument of 50 pixels, so that the frame that is returned by randomSquare is a 50 by 50 box, just like we used previously for our ship and alien buttons. Now let's use what we've written so far to generate and add multiple spaceships and aliens to our view instead of just one. To begin, we will add a label to our view that will serve to display the current level the user is on. For this, we will unhide the utilities sidebar, find a label in our object library, and drag it into our view. We will right-click and drag from IB outlet into our assistant editor from our new label, and name this object level label. We will also create a new variable called currentLevel to keep track of what level we're on by typing this line. Next, let's write code to generate a level. We will begin a new function called generateLevel. Inside of generateLevel, we will increment our current level variable. This means that we will write a line of code that will add 1 to current level's existing value every time the function runs to keep track of what level we're on. We can do this by typing currentLevel equals currentLevel plus 1, or by typing currentLevel plus plus. Since we want our level label to update with the right level number every time we switch levels, we will use this new current level value to update our level label. We can do this by typing this line. Text is the attribute, or the setting, in level label that we wish to change. The text in quotes is the string of text that we want the label to display. The current level portion of this code, preceded by a backslash and surrounded by parentheses, is simply telling Swift that we want to use the value of this variable, current level, in this string of text. If we removed the parentheses and the backslash, label would always say level current level in our view, rather than the correct level number. Now we will generate multiple objects using a programming concept called a loop. Loops are pieces of code that are repeatedly executed a certain number of times based on a certain condition. For our program, we'll write our loop like this. For is the keyword that Swift uses to tell that we're about to start a loop. Level is the loop's iterator, which means that it is the value that our loop will check each time it runs to see whether it should continue looping or stop. 1 is the start value. This means that when the loop first runs, level is set equal to 1 to begin. The ellipses are the range. This means that our iterator level will be set to equal each value in between our start and end values, incrementing with each loop. And current level is our end value. This means that once level equals current level, our loop should stop and our program should continue past the loop and on to the rest of our code. With each run of our loop, level will be incremented up by 1 until it equals current level. This means that this piece of code will loop as many times as the level we are on. Everything inside our loop will execute each time the loop runs. Let's move our calls to make ship and make alien inside of this loop. This will cause our program to create one new randomly positioned alien and one new randomly positioned ship for every run of this loop. Since the loop runs as many times as the level we are on, this means that the number of aliens and spaceships in a level will equal the number of that level, so the game will be more difficult at higher levels. In our next screencast, we will finish up our game by adding code to track the number of aliens and spaceships in our view, as well as the level we're on, to make sure that we can tell when the player loses. We'll also add a start button to our game to make it easy to play again and again. Thanks for watching, and we'll see you soon.